about Cold War Social Science Section 2. And this time we're going to talk about Cold War science, well, Cold War society in the whole, but in particular Cold War science with Sputnik and scientific inquiry. So let's get right into it. So the Soviets launched the world's first man-made satellite October 4th, 1957. It is known as Sputnik I. It's very small. It's not bigger than a basketball, but this has a lot of repercussions in the United States. It's going to lead to a lot of things getting pushed forward in the U.S. as kind of a reaction. And then a month later, November of 1957, the Soviets sent Sputnik II into outer space. That carried a dog named Laika into outer space, and it was much, much larger than one. Obviously, he was able to carry a dog named Laika. The military implications of this really scares Western officials because the rockets that are used to launch these satellites into space are also the same intercontinental ballistic missiles that launched that can allow the Soviets to deploy nuclear weapons remotely and had a range of 1,000 miles, which isn't that large, but if you put your missiles in the right place, it can be quite large, right, of a range. So at this point, nuclear strikes required a pilot to fly over the target, drop the bomb onto the target as such. But with ICBMs, that's kind of gone. And also now you can have this surprise attack because a plane will be seen on radar. These ICBMs may not be, right? Or if they are, they're just going so fast, right? All you're going to be able to do is kind of do a retaliatory attack, right? The Democratic senator from Texas at the time, one of the two Democratic senators, Lyndon B. Johnson, who obviously will become much more important later on, calls this the greatest national emergency since Pearl Harbor. So that's how serious people are taking it. However, despite this public worry, the president at the time, Eisenhower, didn't know that the Soviets' nuclear weapons technology was way behind the U.S. What does it want me to do here? What? That doesn't make any sense. It continued to be far behind the U.S. Due to top secret intelligence reports, due to spies, essentially. And so with this knowledge, he tried to calm and reassure the Americans, even though the Soviet Sputnik propaganda was making the Soviets look much stronger than the United States. And in reaction, I don't know if in reaction per se, I think it's probably in reaction. Eisenhower announces the creation of NASA, the National Aeronautics and Space Administration, which will become the main force of the space race in the 1960s. And then he also uses urgency of the moment to create popular support for new initiatives meant to bolster American education in science and math and engineering and in foreign languages. So essentially your STEM classes plus foreign languages. 1958, Congress had passed the National Defense Education Act, which designated $1 billion of federal spending to fund research grants, to student loans, to scholarships and curriculum development. And all of these are towards the goal of aligning America's education system with its national security needs, which is a little scary to think about that, American students are being educated to help the military, right? More than anything, right? If that's like the thing that they want the most, it's a little scary. And so we do see the Cold War significantly increase federal investment in post-secondary education, which is where a lot of these innovations are occurring. This is despite McCarthyism decimating the ranks of university professors. University professors, on the whole, tended to be a little more left-leaning, a little more liberal, and in some cases communist. So a lot of them got driven out of academia because of McCarthyism. Science itself becomes a contested battlefield during the Cold War, except for high-profile fields like atomic physics and aeronautic engineering, where they were both kind of in agreement. We see that the Soviets and the United States have different opinions on science, which is interesting. The U.S. champions itself as the leaders of pure scientific inquiry and international collaboration, which, as we'll see later on, not totally true. This is a part of a larger strategy to contrast the openness and freedom of the liberal democracy of the United States, right? The ability to go do whatever you want, right? To believe whatever you want, with the insularity and oppression of Soviet communism, which, of course, the openness and freedom of liberal democracy also has an asterisk on it because you can't really believe in communism, right? But anyways, evolutionary biology is the field where we see the most dramatic kind of difference between the Soviet Union and the West. Where a Soviet agronomist by the name of Trofim Lysenko rejects natural selection, which is the core idea of Charles Darwin's theory of evolution, right? The idea that the genetics of different animals will adapt to their environment, and then the ones that have those genetic mutations that are more able to live in an environment will survive and then pass those genes on, right? Creating kind of a stronger animal in that sense. And so he starts to reject natural selection shortly after World War II, and instead he proposes an alternative theory of genetics where he believes that biological traits resulted entirely from the immediate environment and they are not inherited, right? So that instead of natural selection occurring over time, basically what he's saying is that your genes will develop different ways to cope with the environment that you live in. And for example, he believed that rubbing ice on seeds would produce plants that thrived in cold water. As long as it's not ice 9, maybe he's right. And the key thing about this is that he believes that his genetic theory adheres to Marxist principles of something, whereas Darwin's ideas represent the corrupt bourgeois values of capitalism. I guess, Marxists think people can kind of make themselves stronger, and maybe capitalism is like it's all about your family. I don't know. I don't know where the logic comes from. And so what we see is Soviet scientists that are unwilling to embrace Lysenko's model genetics. I believe they called it idiosyncratic, which is basically like just wrong. Risk losing their job or worse because Lysenko's model had the official backing of the state. And to American scientists, Lysenko's claims are dangerous because they're not true, or at the very least, they lack empirical evidence, right? And they're also really concerned because Lysenko is privileging a political ideology over scientific truth. And this was a perfect opportunity for the United States. It's a perfect foil, right? The perfect opposite for the U.S. to kind of launch its ideas off of, right? To showcase the United States as this defender of freedom against totalitarianism. So yeah, the State Department seizes on scientific inquiry as a metaphor for the wider Cold War struggle, beginning to recruit scientists who are willing to attack the Soviet Union's politicization of science and promote the idea that the U.S. supported science for science's sake. However, the United States did not support science for science's sake all the way. In fact, this kind of theme asks the U.S. government's self-serving manipulation of international scientific networks and conferences, which the historian Audra Wolfe kind of exposed or at least demonstrated. And by 1967, the U.S. was spending $15 million annually to fund 38 private scientific organizations secretly, such as funding academic journals, such as publishing textbooks, and deputizing scientific attachés to be both goodwill ambassadors and spies, right? And this is soft power, right? This isn't pure, military power. This is like cultural power of that the United States is trying to expand. But there was very little evidence that this was effective. But again, it illustrates an example of the soft power resources tapped by U.S. officials during the Cold War. All right, so let's talk about Cold War math here for a little bit. Because math in the atomic age is also very important because we all of a sudden see the need for more sophisticated, I guess, since there's some more sophisticated models of things that are going to happen, specifically to project the cost of nuclear attacks and counterattacks and the hypotheticals that come with that. How many civilians were likely to die if a hydrogen bomb was dropped on New York City? How far would radioactive fallout extend? How fast could a counterstrike reach Moscow? And so we see computers programmed to analyze specifically these hypotheticals to generate valuable data that gave decision makers an additional tool. Of course, none of them can answer the question, how could the United States win the Cold War? Right? But the big development in mathematics during this time period is game theory, which is also in economics as well. It was pioneered in the 1940s by a group of mathematicians led by John von Neumann, which basically begins to formulate a system for analyzing outcomes in games of chance, right? So what are the best options based on your chances available, right? We see these translated into business and international affairs pretty quickly, but then the Cold War, scenarios that game theory could be applied to made this very appealing to national security officials in the United States. Because this was a way for them to hopefully create some sort of rational order in this irrational situation, right? The uncertainty and sanity of global nuclear war. So what game theory really likes to do is reduce reduced things to a series of games, right? Game theory is literally all these different kind of games. I can't tell you about Chicken and Stag Hunt, but Prisoner's Dilemma, I do know a little bit about. Basically, the prisoner's dilemma is that two people are arrested for a crime, and they are both interrogated independently. And basically, the interrogators tell each of them that if you cooperate, you'll get a worse sentence. If you cooperate, basically, if they both cooperate, then they're both in trouble. And if one cooperates and the other doesn't, then the one who didn't cooperate is in more trouble, and vice versa, right? And then if neither of them cooperate, they're also going to be in trouble, right? So how does that play out? It's something along those lines. It's been a while. I learned a little bit about it in college because I'm minored in economics, but again, I'm an old man now. So, but what game theory allowed them to do is make the Cold War rivalry, and especially the nuclear rivalry, appear predictable. And especially the predictability of the Cold War rivalry for the national security officials was due to John Nash, who was a Princeton scholar recruited by the Rand Corporation. And if you've ever seen the movie A Beautiful Mind, it is about him. It's a very good movie. The Rand Corporation was a think tank that was founded to facilitate cooperation between academic elites and military elites. And John Nash proposed that in non-cooperative games, which are games where the two sides are not cooperating, each side would pursue strategies designed to maximize their individual gain while assuming that the other side would do the same, right? And this produced an optimal strategy for each side known as Nash equilibrium, right? So if they both recognize that, what the best option is for the other side and for themselves, then they will pick kind of based off of that, and they'll both tend to pick the same idea. And for nuclear warfare, this produces stalemate because the options were, if we both launch missiles, if we launch missiles, they're going to launch missiles, they're going to attack us, right? And so what's the best scenario for us based on this knowledge? The best scenario for both of them was to not engage in nuclear attacks, right? And so we see Secretary of Defense Robert McNamara, his strategy of mutually assured destruction is formulated a lot on Nash equilibrium and game theory, stuff like that. Okay. But that's going to do it for this one. The next one will cover nuclear war and the military-industrial complex. But until that next video, thank you guys so much for watching, and I will see you in the next one.